All right, so chapter 9 is we're talking about log functions. And yesterday we talked about the definition of a log function, or a fact that if I have a log base a of n, this is, or let me use x and y. If I have log base a of x equal to a number, what this really means is that this is the exponent that goes on a, the base a, to give you x. Okay? Another way of saying this, the equivalent statement is a to the power of y will give you x. Okay? So we did some examples, like here's a basic one, log base 4 of 81. Oops, not that, 64. Log base 4 of 64. What's the power that will go on 4 that would give us 64?
3.
3. Okay. And you can see this is the same as saying 3 to the 4th is 64. These are both true statements. Okay. So these are complement each other. All right. Now we also did some weird ones like log base square root of ooh, this is interesting. See how good you guys are. Log base square root of 16 is 2. 16 to what power? Square root of 16 is going to give me 2. Well, first of all, what is square root of 16?
4.
4. So 4 to what power will give you 2?
1/2.
A half. Okay. So if you took the square root of the square root of 16, that's a square root of 4, which is 2. All right, that one was a little more challenging, but you get the point. Is this is the exponent that goes on the base that will give you the input. Okay. Now, did we do estimating? Did I talk about estimate? I can't remember. Oh, I guess I can always just go back and look, right? Where did we end? No, I did not. Okay, good. That's what I thought. I thought I didn't get to that with you guys. So we can estimate some of these too. And this is useful because not everything works out to be a proper integer. Sometimes we get decimals. And usually that's what we use our calculators for, but as budding mathematicians who are going to be engineers and doctors and stuff like that, some good logical thinking will also get you the answer. I can make up examples, or I guess I might have to because I don't. Oh, here we go. This is what I want to use. Okay. All right. Find or estimate. We can't find it exactly. So estimate, here's one. Log base 3 of 10. Log base 3 of 10. So remember, my equivalent question is 3 to what power is going to give me 10? And you can see pretty quickly here that it's not going to be a whole number, right? Because 3 squared is 9. And 3 cubed is 27. That's a big jump. I ain't going to get 10 with a whole number. Yeah, 2 something. When you say 2 something, you mean 2 point something, right? So this is about 2 point something. Let's say we're going to estimate it to be about 2.1 because 10 comes, and maybe even smaller, but 10 comes right after 9. So you know it's going to be really close to 2. So like about 2.1. Okay. So that would be a good estimate for that. How about this one? Log base 5 of 20 is about what? 5 to what power will give me 20? 5 to the first is 5. 5 squared is 25. About 1.9. It'll be 1 point something. And we'll estimate it. We'll go with a beer. Sure, 1.9. I think 1.8. Did you put in a calculator a beer, or that's a real guess? Okay. All right, good. 1.9. So we'll keep it then. It's real. All right, let's look at log base 5 of 4. Log base 5 of 4. Again, this is going to be an estimate. I'm asking myself 5 to what power is going to give me 4? Well, look at here. 5 to the first is 5. Isn't that already bigger? So now my estimate for that decimal has to be what? Slightly less than 1. If 5 to the first gives me 5, then I need something smaller to give me 4. Does everybody see that? So we're going to say about 0.8. Is that okay? I have to go down to get smaller than 5. Any questions? All right, so you can estimate logs, even if they're not exact. Just remember, it's the exponent that's going on the base that will give you the input. All right, so here's a little fun fact thing to notice. Some fun facts. Okay. Let's find log base 3 of 3 to the 5th. Okay. So the question is, here's my base. What power will go on my base 3 that gives me 3 to the 5th?
5.
Yeah, it's 5. Right? 3 to the 5th is 3 to the 5th. That's true. Okay, let's try another one. Find log base 4 of 4 to the 7th. What power goes on 4 that will give me 4 to the 7th?
7.
7. Yep, it's right there. Okay. All right, so you're probably thinking like, okay, Anne, that's like, hello, super obvious, right? If I'm asking myself to solve this, of course these are the same, right? 4, that power that goes on 4 is 7. But look at this one. Okay. Log base 9 of 9 to the square root of 7. Well, it's similar. 9 to what power will give me 9 to the square root of 7? Square root of 7, right? That's the power. It doesn't matter if it's weird. That's just the exponent that goes on 9 that will give me the input. All right, what about, so what do you guys notice here? Let's make up a rule. When what and what are the same? If I have log to some base, let me make it a color. If I have log to some base, and then I have, let's say A, and this is the same as the base. What is it equal to? I'm sorry. That's not what I was saying. The things that are the same are these. So these are the same. And this is my exponent. Then it's just this exponent. So in using variables, okay, so that's what it is in words. If I want to write this in an algebraic statement, it's log base a of a to the power of n. It's just going to be that exponent. Okay, so when the bases are the same, it's just the exponent on the a. Any questions on that? Okay. All right, let's solve some log equations. What we're going to do is we're going to solve some basic log equations. Okay. So here's an example. Solve log base 3 of x equal to 4. So right now what we're going to use is the definition. Use definition to rewrite without log. Okay. See how that x is kind of trapped in the log part? Okay, it's inside here. I'm going to use what I know to rewrite this. So 4 is the what?
Exponent?
Yes, thank you, Joanne. The exponent that goes on what base?
3.
Yes. Will equal what's inside the parentheses, the input. Okay. So an equivalent statement is 3 to the power of 4 is equal to x, which means that x is 81. And this is really easy to check because if I do log base 3 of 81, that's going to be, the power is 4. Okay, so log base 3 of 3 to the 4th. See? Any questions? All right, here's the second example. So sometimes the inside is not just x, okay? It's going to be some kind of expression with x. So x minus 3 is equal to 3, right? Okay, what's my equivalent expression? Here's my base, 2. Here's my exponent, 3, is equal to what's inside, x minus 3. Any questions on how to rewrite that? Okay. If that's truly good, if you're like, yeah, I saw it before you even wrote it, give me a thumbs up so I can see that you guys are not just watching YouTube. Okay. All right. That's a lot of thumbs up. Thank you. All right. So here we go. This is going to be 8 is equal to x minus 3. Add 3. And you get x is 11. And again, it's easy to check. Log base 2 of 11 minus 3 is log base 2 of 8, which is 3. Okay. All right, here's one more. It's nice when these are just these simple little loggy equations. Ooh, I like this one. I like this one. All right. 2 times log base 4 of x plus 2 is equal to 1. Okay. Now, we can't just jump right in yet because this 2 messes up my definition. Okay. The definition is rigid. I don't know what it means to be 2 times that. Okay. But we can isolate the log term. And then we can use our definition. Okay. Definition doesn't say anything about 2 times it. So I'm going to take this equation and divide by 2 on both sides. Then I get log base 4 of x plus 2 is equal to 1/2. Now I got something, okay? This is the exponent that goes on my base of 4 that gives me my input. What is 4 to the 1/2 power? Anybody and everybody?
2.
2, right. That's the square root of 4, which is 2, which is equal to x plus 2 minus 2 minus 2. And x is 0. Well, that was kind of anticlimactic there. So x is 0. Okay, that's fine. Is it okay to put 0 in a log function? Anybody remember? What is the domain restriction on logs?
It has to be greater than 0.
Yes. Now, here's the thing though. That's when it looks like this. The input has to be greater than 0. On this function, I didn't have that. I had 2 times log base 4 of x plus 2. So my input is x plus 2 that's got to be greater than 0. So that means my inputs have to actually be greater than what number?
-2.
-2, okay? This is the domain of this function. And 0 is within that domain. 0 is bigger than -2, so it's fine, okay? So this, this log equation, no problem. I can plug in 0. I'll get 2 times log base 2 of 2. And then this is log base 2 of 2 is the power that goes on 2 that gives you 2, which is 1. Oh wait, the base wasn't 2, it was 4. I was gonna say we're about to get something wrong. Okay, sorry, let's start over. Log base 4. So what power do I put on 4 to get 2? It's 1/2, and that's 1, which is 1. So you see the solution works. We're going to talk more about domain in a minute. I'm going to come back to that and talk about it a lot more, as a matter of fact, but let's, okay. Let's look more closely at the log function. Let's look at the graph. Let's graph f of x is log base 2 of x, okay? So all I'm going to do for right now is plot a bunch of points and see what happens. So I want to put in 0, 1, 2. We're going to put in 4, -1, -2, 5, and then 1/2 and 1/4. Oh, stay there. Okay. Now, let's do some plug and chug here. So let's look at the case when x is 0. So I'm going to put in f of 0 is log base 2 of 0. So I'm basically asking, okay, 2 to what power will give me 0? What do you guys think? What can I raise 2 to? What power can I raise it to get 0? Well, let's try some stuff. It's crickets out there. So 2 to the power of 1 is 2, right? Nope, not helpful. 2 to the power of -1 is 1/2. Nope. What if we tried 2 to the power of 0? What is that?
1.
1. That is also not 0. So what are you guys feeling here?
It doesn't touch 0.
It doesn't touch 0. There's no solution. Okay. This is does not exist. Does not exist. And if you look at what I just said about your domain restriction, has to be greater than 0. 0 does not go in my function. All right, so let's try some others here. F of 1 is log base 2 of 1. So 2 to what power will give me 1?
0.
0. Yeah, I just did it. It's right above us, right? So 2 to the power of 0. So this is the point 1 comma 0. Now, x is 2. F of 2 means log base 2 of 2, which means 2 to what power will give me 2? 1. 2 to the first is 1. So this is 2 comma 1. All right, let's try x is 4. F of 4 is log base 2 of 4. 2 to what power gives me 4?
2.
2. If you are not sure, you can stop and think, okay? If it doesn't pop right out at you, it's just that these are kind of exponents we know fairly quickly. All right, let's try 5. I'm sorry, -1 is next. So if I plug in -1, 2 to what power will give me -1? What do you
Nothing.
guys think?
There's no solution for that one, right?
There's no solution. Yes, thank you, Jamil. Okay. It goes back to what we did when we started up here. The input has to be greater than 0. And if I tried to find one, if we just spend some time here for a minute, you'll see that that exponent is either going to make that much bigger, like 2 to the second, 2 to the third, 2 to the fourth. That makes that big, not negative. And then if I try to put in a negative exponent, it's just the reciprocals of those numbers, which are still positive, but now they're very small. So there's no way to get this. So this does not exist. And we also know by this point that negatives are not in our domain. You cannot plug a negative number into this function. Okay. All right, let's try x is 5. F of 5 is log base 2 of 5. And I'm asking 2 to what power equals 5? Does this have a solution? The answer is yes, but it's not a whole number. We have to do an estimate. What would you guys estimate this to be?
2.1.
Yeah, 2.1. Thank you, Christian. So this is a 0.5 and about 2.1. Okay. All right, now if we put in a half, x is a half. F of 1/2 is log base 2 of 1/2. 2 to what power will give me a half?
-1.
-1. So this is the 0.1/2 -1. You know what? I'm going to throw in here real quick 1 over 32. All right. What is x of the 1? X is 1/4. F of 1/4 is log base 2 of 1/4. So again, the question is 2 to what power will give me 1/4?
-2.
Yeah. 2 to the -2. Okay. So -2. So that means that's the exponent is -2. This is the thinking. Don't mix this up. The answer is the exponent. So 1/4 comma -2. Now, what about 1 over 32? What exponent goes on 2 to give me 1 over 32?
-4.
Close. Go a little bit more.
6.
-5. Okay, so this is 1 over 32 is -5. All right, so now we have a bunch of points. Let's graph this. Remember, anytime you need to graph something, you don't really know what to do. You just plug in points. I don't like that. Let's get rid of it. Start over. Okay, better. All right, so here's X and Y. And so I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so first point is 1, 0. So that goes here, 1, 0. Then we have 2, 1. 2, 1. Then I have 4, 2. Okay, 1, 2, 3, 4, up 2. Okay, right away you should be thinking this is going to be some kind of curve because that's not a straight line. Okay. All right, then I couldn't put in -1 or -2, so let's go to 5. 5 and it's about 2.1. So 5 and then 2.1. So it's going to be just above this. I just did that so I could get it the right. I don't want that part of my graph. 1/2 -1. Here's 1/2 -1. And then 1/4 was -2. And then 1/32, which I don't even think I can accurately represent that on this graph, is going to be like -5. Okay. So as we get closer to 0, what's happening to this graph? It's getting close to 0, but it will never touch it. So that's what we know. This x equals 0 is a vertical asymptote. And this log graph is never going to touch it, okay? It'll ride alongside it all the way down to -infinity, but it will not touch it. And this, as we get bigger, it will gradually increase. This will gradually get larger. So this is the graph of f of x equals log base 2 of x. And this is pretty much, I mean, this is very similar if I threw in an a. This is basically, it's called the basic function, basic graph of log. Now, some of the other logs we're seeing are not that simple, like that one we looked at where you had like log base 2 of x minus 5. This is not basic. Okay. It's still going to have same properties, but it will be shifted on your axes. This is more in, we're going to talk about that more in pre-calc. Okay. But, and you guys did this actually in workshop. This was the idea behind that activity in workshop, was that you can take a basic graph and depending on what happens to your inputs. So like here, we're subtracting 5 from your inputs. This is going to shift the graph actually right 5 units. Okay. So, but we're not going to get into the details of that. I just want you to understand what the basic graph of what log looks like. Any questions? I know how much you all love graphing. All right. Let's talk about that domain some more. It's all about that domain. Because lots of stuff to look at here. So find the domain of the following functions of the following functions. Okay. A, we have f of x is equal to log base 4 of 3 minus x. All right. So what's true about that input, that inside of the parentheses? This part here has to stay positive. But for which x's? The way we figure it out is we take the inside and we find out, we solve for x when the whole thing will be greater than 0. Is that okay? You guys comfortable with that? All right. So I add x to both sides, but that's the same as saying x is less than 3. You guys see that? Same statement. Here's 3. Not included, everything less than. So this is negative infinity to 3 is your domain, not including 3. Any questions? All right, let's try another one. G of x is equal to log base 10 of x squared minus 3x plus 2. Again, that input, the way you solve this is you take whatever your input is and you make it greater than 0. All right, guys, here's the true test to see if you learned anything last week. What type of inequality is this?
The quadratic?
It's a quadratic, which means it is non-linear. Okay. It is quadratic. This one was linear. So we could just like isolate x and get the answer. But if we have nonlinear, then what is our method that we have to follow? You should have done this on your homework last night. Sign chart. I feel like I should develop an evil laugh, like, wow, you have to do a sign chart. I can do better than that. I'm just feeling a little shy right now. Okay, so f of x is x squared minus 3x plus 2. That's my function. It's greater than 0. To create a sign chart, I have to do my zeros and my undefines. Okay, so step 1, let's find those babies. Okay, zeros and undefines. So we're going to set this equal to 0. What about my undefines? Is this polynomial undefined anywhere?
No.
No. So there are none. That's nice. Don't have to worry about that. All right. So we're going to factor this. -1 minus 2. And then that means x minus 1 is equal to 0. X minus 2 is equal to 0. X is 1 and x is 2. Okay. So those are my zeros. And since I have no undefines on my sign chart, all I have to put on are these zeros. Now here's a question. Are these zeros going to be included at all?
No.
No. How do we know, Christian? Was that you?
Yeah. Because of it's not equal to 0.
Look at that inequality. There's no equal sign there. So we do not include these. Sorry, guys. You don't get to be part of our solution. All right. So here's the thing. What I would suggest when you set this up, when we check regions, use your factored form. I mean, you could use the original, but if you're pretty confident about your factored form, it's just easier to calculate. So here's region 1. Let's pick, how about 0, guys, right? 0 is less than 1. So 0 minus 1 times 0 minus 2 is going to be -1 times -2, which is positive. I don't really care about the number. I just want the sign for this. All right, between 1 and 2, we don't have much of a choice. You have to pick a fraction. Okay, there's no whole number between 1 and 2. So I'm going to pick 1.5. So how about 1.5 minus 1 and 1.5 minus 2? This is going to be positive 1/2, and this is going to be -1/2. And if you weren't sure, I mean, just even if you weren't sure about how to do that calculation in your head, just think about it. 1.5 minus 2 is a smaller number minus a bigger number. You know that has to be negative. So it's positive times negative. This is just negative.
Wouldn't that be -1 and 1/2?
No, because think about $1.50. 1.5, you take away 2. It's like 50 cents. The
Ooh.
difference is a half.
That's my bad.
All right, so then bigger than 2 would be like 3. So 3 minus 1 and 3 minus 2, which is 2 times 1. This is going to come out positive. Okay. Now, my question was this. That is the part that will make the domain good. The possible numbers that work for this function. So I'm going to pick the regions that are positive, these two. So we have -infinity to 1, union with 2 to infinity. And there's my domain. Any questions? All right. So we have good time here. I want you guys, I'm going to start this one off for you, but then I want you to try to finish it. So here's my function, h of x equals log base 5 of x squared minus 4x plus 3 all over x plus 7. So my inside has to be greater than 0. All right, so you guys take it away from here. Obviously, this is nonlinear. You need a sign chart. Go ahead and get it started. Okay. So if you look at this function, the zeros means you set it equal to 0. And my undefineds in this case will be where the denominator is 0. Is that okay? So I'll go ahead and solve these silently because you may be working on a different part. Okay, so on your sign chart, -7 is my undefined and my zeros are 1 and 3. Are there any questions about how I got that? About solving for that? Are my zeros included?
No.
No. FYI, for log functions, they're never included. Okay, because it's always strictly greater than. All right, so I have 1, oops, I want to put these below. 1, 2, 3, and 4 regions. So I have x minus 1 times x minus 3 over x plus 7. This is what I'm plugging into each time. And then, so for the first one, let's pick -8, shall we? So -8 minus 1 times -8 minus 3 all over -8 plus 7. And then that gives you -9 times -11 all over -1. So you're going to have positive 99 over -1. So that's going to come out negative. All right, sweet. What about the next region? What number did you pick there? Anybody want to share?
I just did 0.
Yes, 0. Look, it's right here. Ooh. Okay, so 0 minus 1 times 0 minus 3 all over 0 plus 7, which is -1 times -3 all over 7, which is positive because it's going to be 3 over 7. Positive. All right, in the next region, just really, we can only pick 2, right? I mean, if you want the only whole number in there. So 2 minus 1 times 2 minus 3 all over 2 plus 7, which is 1 times -1 over 9, which is -1/9, so that's negative. And then lastly, 4, we'll pick 4. 4 minus 1, 4 minus 3, 4 plus 7. So that's 3 times 1 all over 11. It's all positive. I don't even need to finish that. Any questions about that? All right, so my question wanted to know where it's going to be positive. Where is it greater than? So from here to here and here to here. So the correct answer for your domain is -7 not included to 1 union 3 to infinity. Okay, any questions? Oh, I finished just on time.
I
Yeah.
have one question.
Yes.
So if there's no denominator, the one do we set not equal to 0 or not equal to x?
Yeah, there's no denominator. You can't do that.
Oh, okay.
All right. I will stay on for a few minutes if you want to say if you have questions. Otherwise, have a great break. Don't forget to do your quiz. I will see you guys next Monday. Be safe. Thank you, Albana. Oh, let me stop the recording.